video we are going to discuss about ideal operational amplifier. So it is having differential input and single-ended output. So if I draw the circuit diagram, you have V naught. So this is your V2 and this is your V1. So if I draw the transfer characteristics for this V0 and so this is my input voltage, right, VID. This is a differential input and you have a single-ended output, which is so if I draw the transfer characteristics to V0 versus VID, you will get linear for this. And this is plus and this is minus supply, so this will be plus V and this will be my minus V, okay, and it gets saturated after this point, okay, before this point. So this is nothing but a slope A. Okay, the difference between these two is about 1 to 2 volt. So I can write this V0 is equal to A times V1 minus V2, right? So here the input impedance of the opamp is infinity and output impedance of this opamp is equal to 0, okay, and it has a infinite voltage gain, that is A is equal to infinity, okay. Then the value of bandwidth that is also infinity. Then CMRR, common mode rejection ratio, this is nothing but AD by AC, that is also equal to infinity. Then slew rate, okay, slew rate, that is also equal to infinity. So this will not alter, okay, it carries this, there is no drifting in the characteristics of this opamp due to temperature. Next, it has zero offset, that is V1 value is equal to V2. When V1 value is equal to V2, V0 is equal to 0, right? Because we know that V0 is equal to A into V1 minus V2. So if both the values are same, so the output is equal to 0. So these are the characteristics, okay. So if V1 is equal to V2, that is not equal to 0, okay. So there exists a common mode input signal, okay. So this also in response to which the ideal op-amp has to produce zero outputs. So this characteristic is called as common mode rejection. So you can see the op-amp which consists of a transistor, right? This has to be biased in such a way that it has to be operated in the active region. So therefore the output voltage is limited by this output voltage level, right? That is, it will not reach the saturation voltage like V plus and V minus. So this region is the region of operation is called as linear region, right? The output voltage is in proportional with A, right? So and the current which is flowing through this input terminal of the op-amp, that is, let me take this one as I1 and I2. Okay, so I1 and I2 value is equal to 0. Okay, because it is having the infinite input impedance. So any signal will get inflicted, right? That is so next one is the gain of the ideal op-amp is infinite. So since the voltage between the inverting and the non-inverting terminal is 0 for a finite output voltage, is essentially 0 for a finite output voltage, right? So the output voltage V0 is independent of the output current drawn from the op-amp. Okay, so V0 is independent of output current, since output impedance is equal to 0. Okay, so the output can drive the infinite number of the output devices of any impedance value. Okay. So since the input impedance is high and the output impedance is low, with respect to the feedback impedance connected externally, and if the voltage gain is sufficiently high, then the resulting amplifier performance becomes solely determined by the external feedback component.